The second part of dealing with our systems of linear inequalities is graphing them and looking at where our solution area could be. And with inequalities, you have to remember when we dealt with linear inequalities, we had to shade either above or below a line, and we also had to deal with a solid line or a dashed line. So we need to kind of remember how to do this. So I have a few examples here. One, just a few reminders. We solved the inequality and put it in slope-intercept form. A reminder, slope-intercept form says y equals mx plus b, but that equal sign could be less than, greater than, less than or equal to, or greater than or equal to. It could be any of those symbols. And then based on the symbol that we have, we are going to either do a solid line if it says or equals to, so less than or equals to, or greater than or equal to. If it does not say the or equal to part, it will be a dashed line. And then we are going to shade either above or below said line. If it is greater than, we go where the y's go above. If it is less than, we go where the y's go below or smaller than. So we'll go underneath the x-axis. So in my first problem here, I have y is less than or equal to 5. We have to also remember, just to give you a little quick reminder, we have to remember Hoy Vux. Hoy Vux tells us if we have vertical lines, horizontal lines, and what those equations look like. Y equals something or y something with no x is a horizontal line. So we are going to make a line where y is equal to 5. 1, 2, 3, 4, 5, which is here at the very top. It is a less than or equal to, which means it is a solid line. So we have a solid line going across. And it says y is less than. So we are going to shade below that space. So I'm going to shade this whole area and say that that is all a part of our potential solution. What we want to do is find where our two equations, our two inequalities overlap. And so we're going to see where the two shading spots cross each other. And that's going to be our solution space. So the next equation that we are going to look at is y is greater than 3x plus 1. I'm going to sneeze. Oh, so sorry. So y is greater than 3x plus 1. My y-intercept is 1. Some dog hair at my nose or something. And our slope is 3, which means we go up 3 and to the right 1. So I'm going to go up 3, 1, 2, 3, to the right 1. Up 3 and to the right 1. If we need to go to the opposite direction, we can, just to make sure we make a straight line. We can go down 3, 1, 2, 3, and to the left 1. Down 1, 2, 3, and to the left 1. This is just a greater than symbol, not a greater than or equal to. So it's not going to be a solid line. It's going to be a dashed line. So you can just make some dashes, or if you want to do a solid line and then erase some parts. I know kids do that as well. So some dashed lines connecting all of the points I made to show where that space goes. And then it says y is greater than, so it's going to be in the larger part, or where y's get bigger, which is going to go up. So in this situation, y's are getting larger on the top side of this line. So I'm going to shade this area as well. So it's going to be both pink and blue. And that is our solution area where the overlap is. So this space here is our solution area. So points in that space is going to be a part of our solution. Points that are not in that space are not going to be a part of our solution. So potential solutions include, we've got 2, 3, 4, negative 1, 4. We have -4, 3, and -4, -1. Non-solutions are going to be only in the pink space. So we can talk about things on the right side of our graph. 1, 2, 3, 4. So you can talk about like 4, -1, or 4, +3. Anything in that pink space is going to be considered a non-solution. So I want to do this again one more time. We have x, I'm going to color this so we know which one I'm talking about. And dogs are still fighting. X is greater than -2. That, if we look at the box, that is x equals a number. It's going to be a vertical line, and it's going to happen where where x is -2, which is on the left-hand side of our equation. It is not a solid line, it's a dashed line. So I'm going to make a dashed vertical line where x is -2. And it says x is greater than -2. So you have to think about the x values on a graph. Where do they get larger? Is it to the left or to the right? Where do the x values get larger? It's going to get larger to the right, where it gets positive. So this whole space on the right-hand side of that line is going to be our solution for the first part of our system. Now we need to do the second one. The second one, we have y is less than 3/4x minus 2. So we're going to have another dashed line. And we have a y-intercept of -2, 1, 2, and a slope of 3/4. That means I'm going to go up 3 and to the right 4. So up 3, 1, 2, 1, 2, 3, to the right 4, 1, 2, 3, 4. Up 3, 1, 2, 3, to the right 4, which is going to take me off the graph. And so I'm going to do the opposite, which is down 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. And this is also going to be a dashed line. There's no solid line here. There's no or equals to. So do the best you can to make a nice dashed line. It doesn't have to be perfect. Just show that there is some sort of break in the line. And it says y is less than, so it's going to go below the line. And so this whole area is where y is going to be less than. And then if we look and see the space where the green and the purple overlap, that again is going to be our solution area. So any points in that space is a solution for the whole system. Other points that are not in that doubly shaded area is not a part of our solution.